slideshow. Okay, I don't think we got started in 2.3 last time, so that's where we'll be beginning today. We're still doing polynomials and rational functions, still on the polynomial part. We won't do on until 2.6. We're now going to do polynomial and synthetic division, okay? Because these are things, they're tools that we need to know how to do so that we can better find zeros of polynomials. Remember, that's what the last section was all about. So we'll use long division to divide polynomials by other polynomials. Now, do y'all remember how to do long division by hand? You punch it on the calculator, right? No, okay? We're going to do a real quick review there. Then we'll use synthetic division to divide certain polynomials. Not all polynomials you can do, only if you're dividing by binomial that's of this form. We'll talk about that a little bit later. And then we'll use the remainder theorem and the factor theorem to give us other pieces of information that we probably didn't realize we had. So let's start with long division of polynomials, okay? Now, before we do, let's do a long division problem. Let's skip back one, get our pen activated here, and let's do 12 divided into 619164. Looks like a nice round number, right? Okay, how do you do long division? Not on the calculator. How do you really do long division?
You see how many times 12 fits into 61?
Absolutely. In addition, in subtraction, in multiplication, we always start from the right and work our way left. Division, we start on the left and work our way right. We start here and do this into there. That's exactly correct. How many times will 12 go into 61? 5 times. Then what do we do? Wait, not yet. We multiply. 5 times 12 is 60. Then we do what? Subtract. And then what? Bring down. So then we do 12 into 19, right? How many times? 1. Then we multiply and then subtract. And then bring down. Okay, next. 12 will go into 71. How many times? 5 times again. Okay. We can even put our comma there. Okay. 5 times 12 is still 60. And then subtract. And what is it? 11. Then bring down the 6. 12 will go into 116. 9 times. 9. And what do we do next? Multiply. 9 times 12 is 108. And then we subtract, and that gives us 8. Bring down the 4. 7. And guess what? 84. It goes evenly. So we say that 12 will divide evenly into 619,164, which I wouldn't have known beforehand, but it does, okay? How do we know that? Because you have a zero remainder, okay? Let me tell you something else. That means that 12 times 51,597 is 619,164. In other words, these are 2 factors of that number, aren't they? Because it goes a whole number of times. No remainder, okay? So, we see it sort of is like a solution, and it's sort of like a factor, it's sort of like a, it tells you a lot of information there. So you remember, you divide, multiply, subtract. Divide, multiply, bring down, divide, multiply, subtract, bring down, divide, until you get to the end. Last subtraction. If you have a remainder, those aren't factors. They just divide to a certain place. But if you have a zero remainder, they are factors. Very good. So let's see what we're going to do here. suppose you're given the graph of, and you're most of the time not given the graph of, f of x equals 6x cubed minus 19x squared plus 16x minus 4. And it says, the graph shows you, obviously, you have, it looks like you have a 0 right there at 2, 0, right? Looks pretty clear. Now, if they hadn't put the dots in there, you'd look at that and say, is that one? Is it touching at one place or is it two places? They put the dots and indicate it's two places, but it's some number that I can't pick out. It's not on the tick marks. I don't know what it is. But you do know there's a good chance that x equal 2 is a 0. Now, if x equal 2 is a 0, can you tell me a factor for this? Remember those rules? Subtract 2 from both sides. X minus 2 would then be a factor, right? Because if you had known how to factor this, which I don't, okay? I don't know how to factor this, but if I could have factored it, I would have gotten it down to something like x minus 2, and then set it equal to 0, and said x equal 2. Well, you do this the backward way, okay? Name, please. A second. Johnson? I can't hear.
Spencer.
Huh?
Spencer.
Spencer, got it. Okay. I can't hear well. Sean, got it. My hearing is so terrible. Okay. So we do it the backwards, Before we factored and got x minus 2 is equal to 0, then said x equal 2. Now we say x equal 2, so that means x minus 2 is a factor, okay? And since x minus 2 is a factor, because x equal 2 is a 0, we know that x minus 2 is a factor of f. We knew that, didn't we? And that means there exists a second degree polynomial that you can multiply x minus 2 times that to get your original function. In other words, you can divide the x minus 2 into that function and use long division. Later, we'll learn you can use synthetic, but let's do long division first. Now, let's go back here to our previous, clear that out of the way, and do our long division. X minus 2 into 6x cubed minus 19x squared plus 16x minus 4? Yes, minus 4. Okay. Now, time out. Before you try to do long division of polynomials, you've got to make sure of a couple of things. First thing is that both the divisor and the dividend are in decreasing orders of their powers. This is degree 1, that's degree 0. 1, 0. This is degree 3, 2, 1. Blast off. No, that was something else. Okay, so it is in decreasing order. The other thing you've got to make sure you're not missing any terms. Every term's accounted for. 1, 0, 3, 2, 1, 0. All are accounted for. If this went 4, 2, 1, 0, you'd have to move that down and put a 0 x cubed in there. Okay? You always have to account for every term in the polynomial, in your degree. Okay? So, we've got them. Where do we begin? We start from the left and do x into 6 and 3. We divide. How many times will x go into 6x cubed? 6x squared times. And then what do we do next? Multiply. 6x squared times x is 6x cubed. And 6x squared times a minus 2 is? Say again, negative 12. What'd you say? X squared, right? All right. Then what do we do? Subtract. Okay, now we've got signed numbers. When we're doing normal long division, they were always whole numbers, right? Positive numbers most of the time. Now we got signed numbers. To me, the best way to subtract signed numbers is change signs and add. That just, to me, helps me avoid error. I don't like making errors. So I'm going to change that to a minus, that to a plus, and then I'm going to add. That's how you subtract signed numbers, right? Okay, so let's add. 6x cubed minus 6x cubed, 0. That's exactly what we wanted to happen. Minus 19x squared plus 12x squared would be negative 7x squared. And then what do? Bring down the plus 16x. Bring the sign down with it. So see how similar it is to long division? It is long division. What's next? X will go into negative 7x squared how many times? Negative 7x times. Very good. Then what do? Multiply. Negative 7x times x is negative 7x squared. And negative 7x times negative 2 is plus 14x. Okay? Then we do what? Subtract, which I suggest doing change signs and add. Well, now I'm going to have to change that to a minus, okay? And then let's add. And when you add negative 7x squared to plus 7x squared, 0, exactly. And what do you get when you add the next two? Say again? 2x. And then do what? Bring down the negative 4. Bring down the sign with it, okay? And then you do what? No, you divide. X into 2x plus 2 times. Very good. And then you do what? Multiply, and that gives you 2x minus 4. Ding, 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 ding. We have an exact factorization, which we should. If x equal 2 was a 0, x minus 2 had better be a factor. This shows with a 0 remainder it was a factor. All right. We have just factored a trinomial, a quadnomial, a cubic polynomial that I had no idea of how to factor. There weren't any of our tools that would work on it. Grouping wouldn't work. Nothing else would work. But because we knew x equal 2 was a 0, we could test that. And sure enough, found out it was a factor. Now, what does that tell us? What's left over up there? 6x squared minus 7x plus 2. That's what? Yeah, it's what? It's a factor, yeah, for sure. But what might we want to see? Can you factor that again? And it's a quadratic, so maybe we can factor that one. 6x squared minus 7x plus 2. You want to do trial and error? AC method? Quadratic formula? You got your choice. You paid your money, take your choice. Second, trial and error? Okay, let's try it. All right. There's a lot of different factorizations for 6x squared. Give me one. Second? 3x times 2x. That sounds like a good place to start. Okay. Now, where do we look next? The sign of the last term is plus. What does that tell you about these two signs? Yeah, they have to be the same. Since the middle is negative, they've got to both be negative. So minus and minus. Now, what's the only factorization of 2? 1 and 2. Let's try it. I think that won't work. And here's why. You see, this has a factor of 2. If this had a factor of 2, then this should have had a factor of 2, and it doesn't. Okay? Because you can pull a 2 out of here, you can't pull a 2 out of there. That must not be right. So let's change them and put our 2's and our 1's in opposite places. Like put the 2 here and the 1 there and see what happens. 2 here and 1 there. Now let's try multiplying that. 3x times 2x, 6x squared. Yeah, we knew that would work. 3x times minus 1 is minus 3x. Minus 4x would be minus 7x. Yes. And negative 2 times negative 1 plus 2. Yes, we've now got a complete factorization of this polynomial that we didn't think we could factor. Because we thought from the graph that x equal 2 was a 0, meaning x minus 2 had better be a factor. So sure enough, we got the rest of it. Okay? What were their other zeros then? If those are the factors, how do we find our zeros? Set it equal to 0. So that would be 3x minus 2 equals 0, or 2x minus 1 equals 0. What does the first one give you? X equal 2/3, and the second one gives you? X equal 1/2. Very good. Now let's look back at that graph again. This one here could easily be a 1/2, and that could easily be 2/3. And they are really close together. By golly, I think we got it right. Okay? So yeah, we have our two zeros. So to find the Q of x, you use long division, and that's what example 1 does, and they're going to do it again, but I wanted you to do it first. Okay? And here's how they show you how to do it. Again, let's go through the steps. Now, they shift everything down 1. I like to put it over here. It doesn't matter where you put it, the end. So x will go to 6x squared, x cubed. How many times? 6x squared times. Now, I do it this way sometimes. The coefficient here goes in the coefficient there. 1 will go into 6, x will go into x cubed, x squared. If that helps you see it better, do it that way. Then you multiply 6x squared times x is 6x cubed. 6x squared times minus 2 is minus 12x squared. Now they subtract without changing signs and adding. You can do it if you are comfortable doing that. To me, there's so likely a chance for sign errors. I like to change signs and add, because that to me is easier. Okay? So either way you want to do it is fine. If you can subtract that, I know that goes to 0. I have to stop and think about, does that go to plus or minus 7x squared? Or is it minus 31? No, it's not. That's adding. So if you change signs and add, to me it removes ambiguity. But however you do it, minus 7x squared, you divide again. X into minus 7x squared is minus 7x. And multiply again, negative 7x squared plus 14x. I like to change signs and add. That gives me 2x. Bring down the minus 4. X will go into 2x plus 2 times. Keep the signs little. Be sure you put your signs in there. 2 times x is 2x. 2 times negative 2 is negative 4. Ding, ding, ding. Subtract when you get a 0. That means that was a factor. X minus 2 is a factor, meaning x equal to was indeed a solution, which we thought it was looking at the graph. Now we know it was. Okay? So that's long division of polynomials. Pretty simple, right? Straightforward, just like you used to do long division of numbers. If you can remember back that far. Did you ever do long division of numbers? Please say yes. Yes, good. All right. All right. Now, so from that division, you can conclude that this big old hairy polynomial here factored into the binomial times the trinomial. Sure enough. Well, so if we factored that far, why don't we see if we can factor again? And they did. They don't show it, but they did. They factored this into this, exactly what we got, which also enables us to give us our zeros. If you know the factors, you know the zeros. If you know the zeros, you know the factors. All right. You pay once and get it twice. Okay. For example, in example 1, x minus 2 was a factor of that polynomial. Long division process produces a remainder of 0. Often the long division will produce a non-zero remainder. That means whatever you divided is not a factor. Okay? In this case, it was. Okay? So let's do this one. Okay? I wish they hadn't done it for us. So let's do it here. And by the way, every example, including example 1, has a checkpoint. Please do your checkpoints. First opportunity you have, do those checkpoints. So let's do another division. Let's get back to someplace where I can write. Here, this will be a good place to write. Okay, x plus 1, will go into x squared plus 3x plus 5. Okay? Will it? What would we do first? X into x squared, how many times? X. If you like the way the book does, shift it down one. I don't care. Next, multiply x times x is x squared plus what? Plus x. And then subtract. This one is easy to subtract. That goes to 0. This becomes 2x. Or you can change signs and add. Next, bring down the plus 5. Next, second. Okay, x will go into 2x plus 2 times. Then you do what? Multiply, and that gives you 2x plus 2. And then you subtract. That goes away, and that leaves you a remainder of 3. Now, I don't know if you remember back in long division, you could either write, say if your answer was 12 with the remainder 3, you could write it 12 or 3. Okay, that was how we did way back in early grades. But sometime later, they said, oh, well, let's just do that. 3 over, say if that was dividing by 11, 3 over 11. And that would work. Okay, remember that? So we could say plus 3 over x plus 1. Your remainder over your divisor. Okay? So that's another way you can write your answer. Now if you continue with calculus in a couple of terms, you will find out, maybe 3 terms, Cal 2, you'll find out you'll be doing long division of polynomials again when you're trying to integrate rational expressions, okay, which we're going to do, the rational expressions we'll do in section 6, integration you'll do in calculus, and you'll do this very thing there too, and it'll make life so much easier. Okay, so let's see what they got when they did it. There they got the same thing. X plus 1 will go into x squared plus 3x plus 5. X will go into x squared. They put the x over here. X times x is x squared. X times 1 is x. Subtract, and you get 2x here. Bring down the 5. X will go into 2x plus 2 times. 2 times x is 2x. 2 times 1 is 2. When you subtract here, those go away, and you're left with 3. The remainder of 3. All right. Next thing they're going to show us, well, let me see, how you can write that very thing we just did. And this is basically what I did before. Remember, division can be written a couple of ways. You can do divisor into dividend in the house, you know it. Or you can put the dividend on top with the divisor on the bottom. This will be dividing into that. But I can remember back, some teacher in elementary school, if you had 135 divided by 11, you put the division sign, put 135 here, and go to town. So, same thing here. This is what goes outside the house, this is what goes inside the house. Okay, so the dividend divided by the divisor is equal to the quotient plus the remainder over the divisor. That's what I was just showing you. Okay? That implies that, okay? Now, do the mental picture here. What's sort of awkward about this construction? What do we not particularly care for? so you probably love them. Fractions, we love our fractions, don't we? But if you don't want to have a fraction, what you have to do is get rid of denominators. How do you get rid of denominators? You can't just erase them, that won't be fair. But what can you do? Multiply by them. So let's multiply this by x plus 1, and you're just left with that. Multiply this by x plus 1, and you have x plus 1 times x plus 2, right? Multiply this by x plus 1, and you get rid of that, and you have a plus 3. So here's the other way. Multiply each side by x plus 1, and you get dividend is equal to divisor times the quotient plus the remainder. And that's how we used to check our long division, wasn't it? If you made your long division and you came out with a quotient and a remainder, you multiply the quotient by the divisor and then added the remainder to it. If you got the dividend, you got it right. Right? Same thing here. The dividend is the the divisor times the quotient plus the remainder. It doesn't matter which order you do it. Okay. So both of these are ways of expressing a division of polynomials. Okay? This is on one line, that's on two, written in fractional or rational form. Okay? So here's our division algorithm. If f of x and d of x are both polynomials, however, that d of x cannot be 0. Any guess of why it can't be 0? You can't divide by 0. So never try to divide by 0. And here's the other requirement. The degree of the d of x has to be less than, and it says or equal to, the degree of f of x. Okay? If they are of the same degree, you can still divide. If the d of x is less than f, you certainly can divide. But if f of x is less than d of x, you already got it in fractional form. You can't get it any simpler. But if that's the case, if d of x has a degree less than or equal to f of x, then there exists a unique polynomials, q of x standing for quotient and r of x standing for remainder, such that the f of x, the original dividend, is equal to the divisor times the quotient plus the remainder. Just like we did in numbers, you do it with polynomials. Now, if that r of x, the remainder, is 0, then we know that these are factors of f. But if the degree of the remainder is less than the degree of d of x, you're through. If it's the same degree, you haven't finished. If the remainder r of x is 0, d of x divides evenly into f of x, and you form factors. Okay? The r of x has got to be a lesser degree than d of x. If it wasn't, you can divide it some more. Okay? So that's our division algorithm. We can either write our answers like that, or you can write it f of x divided by d of x is equal to q of x plus r of x divided by d of x. Either one will be fine. Okay. That's what I just said. Division algorithm can also be written f of x divided by d of x equal to q of x plus r of x divided by d of x. So in the division algorithm, the rational expression f of x over d of x is improper. Now, what do we mean by improper? It doesn't pick up its pinky when it just tips its teeth. No, that's not what we're talking about. Okay? What we're talking about is that the degree of f of x is greater than or equal to the degree of d of x. It's got to be, otherwise you don't divide. But if it is greater than or equal to, it's improper, then divide. On the other hand, the remainder, the rational expression r of x over d of x, has got to be proper. The degree of remainder has to be less than, not less than or equal to, less than the degree of r of d of x. For that to be a proper rational expression. And we'll use that again in calculus. Believe me, I just did it last week. All right, so let's look at the long division, the division algorithm to do long division polynomials. Okay? I already mentioned this. Be sure you write your dividend, that's usually the big, long, hairy polynomial, and the divisor, usually the smaller one, in descending powers of the variable. You've got to have them in those, okay? You can't have them all mixed up, otherwise your answer is going to be all screwed up and it'll be wrong, okay? Also, if you're missing any terms in either the divisor or the dividend, be sure you place a zero, that placeholder there with a zero coefficient for missing powers of the variable, both in the dividend and in the divisor. You can live without it maybe in the divisor, but it's a lot easier to have it there. Okay? So let's see. That gets us to page 138. Now, for some reason, they are skipping examples 2 and 3. So let's go back and do them. Let's find some clean sheet to go on. Goodness gracious. Okay, let's go up here and do it. All right, we're right on this page. Example 2. Divide x cubed I wish they had written it down. Okay. I'm going to write it the way they did. Divide, I hate writing this many words, x cubed minus 1 by x minus 1. So you tell me how to do it. We're going to use long division this time, not synthetic, because we haven't done that yet. How would you do that? What do you put where? Something's in the house and something's out of the house. Wait a minute. Huh? It's time. I'm sorry. No. What was that? Okay. Sorry about that we had a short class today. We'll start next time. If people hadn't been leaving, I would have kept on talking. Okay. We will start at example 2. Sorry that I had the car problem and it messed us up. Okay, let's give you a few homework exercises. Okay, you can listen to them on whatever it's called. Okay, you can do number 7. You can do number 9. You can do any of the odds 11 through 23. Well, let's see. Let's do 11 through 18. Through 17. 11 through 17. We'll pick up the rest of them later. Okay? Good deal. Thanks for your patience. I really appreciate you hanging around. I did not mean to be this late, but the rental car company that my insurance company uses didn't open until 7:30. So when I finally got them, I kept calling a few minutes. Finally, after 7:30, they answered the phone and said, "Oh, yeah, there's no problem. Okay, we can get you a car this afternoon." No, I need to be at work this morning. So you dropped something, it looked like a cell phone phone. It's on the other side. Yeah. Okay. So then I called around, and my wife and I were battling on what we should do. And finally we decided Uber. So we called Uber, and he was 9 minutes away. He was coming from the airport, so he got me here. So that's why I was so late. Yes.
Yes, sir. Would you please show me?
Okay, thank you. You too. What's that?
Would you show me how can I get to this? Like, how do you know x minus 1 to get that?
Okay, because when it says divide something by something, that goes on the outside, this goes on the inside.
Okay, but then over here,
right?
If they don't give me a graph, how can I do? How do I know that x
okay.
minus 2?
That's what I was talking about before. By the graph, it looks like 2 is a 0.
Yes.
So x equal 2 is a solution, right?
Okay.
So if x equal 2 is a solution, x minus 2 has to be a factor.
Okay.
So that's how you choose that.
Then over here they get this one. How can I get that?
Okay. Here they said the same thing. When you divide this by that goes on the outside, this goes on the inside.
Oh, okay. So that means they're gonna give you this for you to do this.
Yeah.
Okay. They're gonna give you the which one divide by which.
Yeah,
one,
exactly.
do that.
Right.
Okay. Because I just don't know like where you get this from
Right.
and where you get this from.
Yeah.
But
Well,
now need to know how to do this part.
Right, exactly.
Yes, sir.
Oh, we'll need to know more
Yeah,
later.
I'll let you know
Okay,
that
right.
part.
That'll be the first step, yeah.
Thank you.
All right, thank you. Good question, by the way.